So welcome everyone to day 3 of panel 5, to this session where we want to speak a little bit about a cross-topic theme, which is today the contribution of buildings for sustainable cities. As you all know, the building stock plays a major role to achieve the goal of sustainable cities. So this is a really important topic that, the buildings must be renovated to reduce energy demand and renewable energies, and they must be expanded to supply the remaining energy demand. And so this is really a crucial topic in municipalities and cities. And that's why we want to talk about that today. First of all, maybe 2 or 3 organizational things. I think we are now at day 3 at the eceee, so you should be all familiar with the Q&A session and the chat. So if you want to ask questions, feel free to go on Hoover and post there your questions in the Q&A session or in the chat, and then we can ask these questions to our speakers. But let me first of all introduce you myself, because it's the first, my first panel as a panel leader. So I'm Markus Fritz. I'm working at Fraunhofer ISI in Karlsruhe as a researcher, and with me today are my co-panel leaders, Cedric from yesterday and Suzanne from Monday, and they both will also, you will see them, I think tomorrow and the day after tomorrow, and they will have a look at the Q&A session, at the chat, so no questions should be lost. Our first speaker is Migena Zula from Linnaeus University, and she will talk about barriers and drivers for scaling up energy renovations. So I think this is a very good introduction into the topic of buildings in terms of sustainable cities. So Migena, the stage is yours.
Good afternoon, everybody. My name is Migena Zula. I'm a PhD student at Linnaeus University in Sweden, and my main research focus is on sustainable built environment and the retrofitting of existing existing housing stock in Sweden. Today, I will talk about our research paper, investigating barriers and drivers for scaling up energy renovation, developed with Mr. Mahapatra and Mainali. We are in front of a climate emergency that's in need to fulfill Paris Agreement, and we need to act fast. Building sector is one of the main sectors to be addressed. Our current building stock is accounted for more than 1/3 of the final energy consumption. In order to fulfill EU targets for a free carbon society by 2015, we need to at least double energy efficient renovation rate that at the moment are around 1%. Member states are drafting long-term strategies and innovative action plans how to tackle the decarbonization of their urban stocks. There is a common agreement between literature that the transition from a single building perspective toward a district level approach, tackling energy renovation, could be the way to go forward. This research tries to identify factors driving or hindering this transition. Systematic literature review is applied, and 85 papers are analytically assessed from a matrix that identifies motivation, barriers, and drivers for uptaking a larger scale renovation approach. Environmental goals and climate mitigation still remain among the main motivation to transit from a single to a district scale approach. Anyhow, different papers bring up the social and urban sustainability at larger scales. The district scale is considered the smallest scale where energy efficient measures could be integrated with shared mobility, integrated solution, and smart city cross-sectoral partnership. Through literature review, different drivers considered as commuting forces exerting pressure beneficial for upscaling deep energy renovations are identified. Grants and subsidies still remain amongst the highest identified drivers to incentivize initial uptaking of energy efficiency renovation at the district level. A shift of the focus in the recent years of implementing EU-funded projects from single building intervention towards building stock renovation has been observed. Anyhow, in different papers, it's pointed out that grants and subsidies cannot be seen as sustainable in the long term. Policies are considered and comes out as one of the main factors that can boost the decarbonization of current building stock. Within the EU framework, the currently updated Energy Performance of Building Directive and Renewable Energy Directive requires the strengthening of position of energy performance certificate and further presence of building passport as a tool that can boost the and speed up the renovation process. When we talk about policies and regulation, we need to point out that the different member states are preparing their national strategies and action plans to tackle energy renovation of their building stocks. Varieties between strategies are observed, thus the regional and local context gains interest and needs to be further addressed by literature in identifying drivers and barriers country-based. Innovation and technological improvement is seen as one of the main key factors to unlock the EU innovation wave, but as well to revolutionize the construction market through prefabrication and industrialization. For this, mass production and economy of scale is needed. Thus, the district scale approach is the appropriate level to address renovation in this respect. Prefabrication and industrialization can cut investment costs of applying energy efficient measures as well as time of renovation construction works. And thus, we can have a less expensive and less intrusive process in general. Innovation construction is a fragmented business sector. Innovative business models are needed to exploit the added value of the whole retrofit. When we are dealing with district scale approach, a large number of stakeholders is engaged in the process, making the process more difficult to manage and complex. Thus, one-stop shop and turnkey models where a single actor is leading the entire innovation process is considered as the way to go forward. The new recast electricity directive has opened the door for creation of citizen energy communities, which have taken a leadership role in community energy production. These citizen energy communities can act as innovative business model and one-stop shop and use the energy production to capitalize the investment costs for district scale renovations. Other innovative business models being investigated through different European projects is the add-on or infrastructure extension through densification of the existing building stock is aimed at the financing of the renovation cost for the entire stock. And this model still is in its initial phase of development, and further research is needed to validate its profitability. Anyhow, it represents a very interesting model, especially for increased population municipalities, where this additional space can tackle the need for more housing, while using within the existing urban layout, exploiting current infrastructure and avoiding urban sprawl, conserving thus nature. Integration of renewable is the last but not the least identified driver within this paper. The district scales allows us to integrate the energy interaction between buildings, assess the optimum balance between energy efficiency and renewables, and consider a broader range of renewables to be proposed and integrated into the energy model. Despite the benefits arising from transiting towards larger scale approach, there are different factors that hinder and obstruct deep energy renovation process at the district scale. Among the main identified barriers remain building regulation, technical barriers in renovation planning, high upfront cost, ownership, knowledge and awareness and trust, and time. Energy efficient measures proposed have to fulfill local development plans and building regulation that sometimes could be outdated and rigid to accommodate innovative measures and tools. This in addition to permission procedures that complex and time consuming, especially considering the large scale of intervention, can be one of the barriers for owners to uptake energy efficient renovation. Energy planning of building stock is of a different complexity level compared to a single building. It is more time consuming and requires a higher expertise and bigger computer capacity to assess, analyze the data and build energy models. Anyhow, the biggest barrier in this respect remains data. And when we talk about data, we talk about data availability and data quality. Although several databases have been developed in the recent years, we need more data and better data. This clash and dispute between the need to publicly access the data and and legal frameworks protecting data privacy needs to be addressed further in future literature as a way to make more data available for energy planning. High upfront costs still remain as one of the main barriers to initiate energy renovation. In the district scale, not only we are dealing with higher initial investment costs, but as well higher expertise in allocating efficiently the cost is demanded. When we are dealing with large-scale renovation, we are dealing with multi-owners engagement with a different background and different needs to be addressed. In large building portfolios, there is a mixed ownership between public and private entities with different long-term interests and visions. This can be problematic, especially when we are trying to build a common renovation model for the entire building stock. Considering the ownership perspective, the relationship between tenants and property owners becomes as a challenge, comes out as a challenge. In several countries, it's requested that there is a prior agreement to energy renovation between tenants and property owners. Tenants in general are hesitant to uptake an renovation not only because of the financial implication and increase of rent costs, but as well because the process is very intrusive in their daily life. An interesting point to be discussed is the split or the ownership of the benefits from renovation. There's not a clear split between the ownership, but there is a common understanding that the end user is profiting from the upgrading of the inner space and living conditions, while the added real estate value is a profit to the property owner. But if we are seeing the benefits from an environmental impact perspective or lenses, we could consider society as the main beneficiary of cutting greenhouse gas emissions and energy usage. In this respect, we could state that energy efficient renovation, especially those of large scale with high environmental impact, could be considered as public goods. Time comes out as a barrier in several papers. Generally, time is considered in the speed concept or tackling down the speed of implementing of the renovation works. This is very important, especially because the process is very intrusive and can become a barrier. But in recent literature, time was developed in the perspective of phasing the renovation. And this gains relevance, especially for large building stocks, when we will need to phase and step the implementation of the renovation works. To have a smooth process, we need to plan the phasing from the initial planning steps, but this will make the process more complex and will require higher expertise, especially during the planning phase. Main discussion brought up within the paper remain with the need to efficiently address current grants and project funds towards project developing sustainable business model and innovative technology and tool developments that could unlock a future self-sustainable innovation wave. When we talk about regulation and policies, the variety and differences of measures measure and address tool between different member states brings the regional and local context in attention. These localities can affect the drivers and barriers, and thus further local or country-based research is needed. Further controversial results within project implementation are viewed within the researched and analyzed papers. Sometimes factor driving some renovation process can hinder others, not only local context, but as well as momentary condition of the entire renovation process come out as relevant. It is important to understand this condition that affect positively or negatively different factors for positive future developments. Split of ownership of the benefits arising from renovation remains an interesting point to be discussed. As previously mentioned, the end-use profits from increased living condition, while property owners from increased real estate value. But the entire society profits from cut down of greenhouse gas emissions. In this environmental impact lenses and in front of this climate emergency and importance, we have the right to consider these energy renovations at a large scale as a public good similar to infrastructure projects. If so, we need to reconsider the position and active participation of local and national authorities in the process. Data availability becomes important when we talk in respect of energy modeling. The dispute between access of the energy data can be seen as a data privacy and digital dignity invasion. Thus, not only this needs to be discussed for future research, but there is a need to take action and draft legal frameworks to regulate this relation. This paper aims to start a conversation of possible technical, economical, and social approach that can boost energy retrofit projects in large building stocks. Holistic approach considering several aspects is still missing. Different drivers and barriers are identified within the context of EU. Anyhow, regionalities and local context makes a country-based approach relevant and needed for future developments. Further research is encouraged to include urban spaces, mobility, and urban lighting as an integrative part of the district overall performance. Additional topics to be considered are the level of comfort, the upgrading of interior space perception, lowering of the noise pollution, and different health issues, while affecting the owner's physical and mental health condition. The renovating of spaces have indirect economic implications. Healthier people, physically and mentally, can lower the public health costs. On the other side, happier and healthier people are as well more productive and perform better in their professional lives. Thanks for your attention.
Thank you very much for this interesting presentation. And first of all, the remark, if you have any questions, please feel free to post it in the Q&A session on Hoover or in the chat on Hoover, and then we can see them and ask them. And as I see we have already some questions. So, Megena, first of all, I think this is a question for clarification. What buildings did you study? Was
Yeah,
it single family houses or multi family apartments? Because it differs from ownership, and so the question is, what are the main difference that you see between them?
it was on general, so it included both of them, but of course the main literature found was on multifamily houses. There is only a few papers on district scale approaches for single family houses, and it makes it very difficult to assess that in that respect. Of course, there are several differences, and especially regarding maybe ownership. And this will vary between different countries' contexts, actually. Where we are sitting in Sweden, single family houses mainly are owned by private property owners. So, but in other countries, that can be social housing that are owned by public entities. So even within the same building group, there are differences that needs to be addressed in this respect.
And you said that you mainly looked at multifamily houses, but
Yes.
do you have a feeling about how these barriers and drivers also appear at the single family house level?
Yeah, I think some of them account the same for the single family housing. So in the single family house level, actually the market is more fragmented and it becomes more difficult to scale it up. Although we know that there are several, for example, examples from Europe, but still they don't have, didn't experience the results that they were foreseen to do. For example, Energisprong from Netherlands is one of these examples that was thought to be spread a lot, but actually it didn't happen so much.
Okay. And I think we will, in the next presentation, hear something about these innovative business models like the one-stop shops to address these scaling challenges, I think. But we have another question. Did you look at barriers and drivers in a theoretical perspective? Because there are different approaches trying to categorize barriers and drivers in the literature. So what is your methodological background or your base for that?
So in general, I tried to classify them based on social, technical, economical barriers, but didn't apply a pest analysis exactly into the model.
Okay. And I think we have no more questions in the chat, but then maybe a question from me. I think the question of data privacy and data availability is really important because I don't know if you're familiar with that, but in southern Germany, there's now a regulation where all municipalities they must prepare a strategic heat plan for the next few years, and because of that, they can now get all data from the district heating providers and the gas providers. So do you think this might be a good solution so that these district heating providers, gas providers, or other energy providers are obliged to give data that you can use them for planning? Or do you think this is a big issue because of data of data protection?
I cannot really give a clear answer on that, actually. This is a very tricky point of discussion. And of course, if we consider our opinion in from the energetic perspective, of course, we would tend to go more into providing the data. But if we're going to discuss it with other disciplines, then they would have a different approach into that. Maybe this, but a solution has to be found in a way so the data is available. Important is that the data is not used for other reasons.
Yeah. Maybe, Cedric, do you have a feeling about that? Because you're working with municipalities in Flanders. So do you have these data protection or data privacy issues there?
In fact, we in Flanders are now working on heat plans. We will provide with our association for all cities and communities, not as a strict plan, but as an inspirational plan. So every city and community and municipality can do their own decision how far they go on collective heating and individual heating. And I think it's a very important decision to make because the strategy you do on retrofit is different if you will have on long term a collective heating system or not.
Okay. And then we have a further question, Migena, who needs to read your findings? So who are the stakeholders that should read your findings for a successful scale up of deep energy renovations in Europe? So are there, or should municipalities read it, or private actors, or heat providers?
Yeah, actually, I would say that private actors and municipalities are more directed towards this finding. It's not considering heat providers and energy providers. Anyhow, it is mainly towards the private actors.
All right. Do we have further questions, or from you, Susanne or Cedric? All right, then I would say we stay in Sweden because our next speaker is from Linnaeus University too, and he will talk about public versus private one-stop shops for energy renovations of residential buildings in the European Unions. And yeah, as I said, I'm really interested in this presentation because the concept of one-stop shop is not so it's not so spread in Germany. So yeah, the stage is yours.
Thank you very much, Marcus. Let me share my screen and proceed. I hope you see it now. Good afternoon, everybody. My name is Jurg Pardales. I'm a researcher at the Department of Built Environment and Energy Technology at Linnaeus University in Sweden. And the concept of my today's presentation is comparative analysis between public and privately driven one-stop shops for energy renovations of residential buildings in the European Union. First of all, a bit of a background to the whole context. Unfortunately, the COVID-19 pandemic that hit the whole world brought residential buildings again back to the agenda, and especially the renovation of it, since our homes became schools for the children that didn't have to go to school and got online classes, offices for us, and in general, places even for socialization. Online meetings, even for having fun with friends or having a drink with friends, became quite the norm. Therefore, redesigning and renovating the house became again relevant. Currently in the European Union, 40% of the buildings are built before the 60s, and that means that they have a higher energy demand. Unfortunately, only 0.4 up to 1.2% of those buildings are currently undertake some sort of energy renovation. European Union, of course, has taken serious initiatives in order to address this issue with the updated Energy Performance Building Directive, with the revised Energy Efficiency Directive, with the EU Green Deal Initiative, and of course the latest one, the EU Renovation Wave Strategy. This low rate of energy renovations is attributed to many different parameters. Among them is the lack of integrated solutions supported by appropriate business model, and the fragmented renovation supply chains that do not allow energy innovations to expand further. In terms of business models, one-stop shop is a business model that can potentially provide the solution and uptake this rate of energy renovations. The objective of the methodology of the paper presented here. First of all, the reason was to present case examples of currently operating one-stop shop business models in the European Union. We would like to analyze those business models with different ownership types, as I said previously, public-driven and private-driven, and compare those models in order to identify commonality, differences, and some patterns that exist in both of them. The methodology used is a records-based research approach from material that business models, the business models themselves have given through webinars. They have given models presentations in conferences, scientific or business conferences, their websites, etc. Of course, this record-based approach was supported by insider knowledge, talking to people behind those business models. And all those business models were analyzed in parameters based on a business model canvas framework. As far as it's concerned, the one-stop shop concept, it is considered an optimal solution, an optimal business model configuration for fragmented value chains. It helps a lot to bridge the competence gaps that exist in supply side of renovations. It offers to homeowners a single contract for the whole renovation and a single contact point throughout the renovation. It is considered a homeowner-centric concept, and it is a concept that it's very strongly advocated by the latest energy performance building directive. And it is a concept that we see it emerging in several European countries. It is also a model that comes in many different types. Previous research has identified 4 main types of this model, and in previous sessions today, I had the opportunity to share that many more typologies come for one-stop shop business models. But mainly, the research we focused has identified facilitation models, which are the simplest form of one-stop shop business models, and mostly focus on advising and motivating homeowners to perform energy renovations. The coordination model, where a single actor coordinates several other actors in the supply chain and supports homeowner with coordination of suppliers of materials and installers. Of course, in this model, we have the one-stop shop provider bears no responsibility of the quality of the work provided. We have the all-inclusive model, which is practically the most integrated form of one-stop shop. And in this model, we have a fully guided renovation process, a single contract, tailor-made renovation packages, and a one-stop shop that bears full responsibility for the quality of the work delivered, but not necessarily of the energy savings that will be delivered after renovation. And of course, the ESCO model, which is quite emerging in multifamily residential buildings, but still its application in single-family houses, it's on a very exploring moment, we can say. As far as it concerns the business models examined in this study, we have 3 public-driven one-stop shops and 3 private-driven. As you can see, 2 of the models public-driven models come from France and 1 from Ireland. And we have in France an ESCO type and a coordination type business model, and from Ireland, a coordination type. And we see that the service provider in both 3 of them are quite different, but they have a common element that we have the participation of a public entity. As far as it concerns the private-driven one-stop shops, we have 1 from Spain, 1 from UK, and 1 from Sweden. Again, we see difference in types between all-inclusive and coordination model. And we have, again, different service providers. In the case of Spain, we have a Renovation Companies Association. In the case of UK, we have a cooperative of supply-side actors. And in the case of Sweden, we have a startup. Regarding the example parameters for each business model, we have some aim from the Onestop Engineers business model canvas, like value proposition, customer relationships, customer segments, activities and capabilities, revenue streams and costs. And we add maturity to examine to which stage of the delivery of the model we are, and some perceived main strengths that each model has. Proceeding to the findings, we can see that regarding the public-driven and private-driven or one-stop shop, some of the key activities are quite similar. Like, for example, on-site visits and pre-renovation audits. We see quite strong provision to access to financing to homeowners from the public-driven one-stop shops, while in the private-driven one-stop shops, it's not part of their value proposition, and where it's given is to selected customers. We see that as far as it concerns the management of renovation works, it is quite balanced between public-driven and private-driven one-stop shops. Regarding the post-renovation inspection and follow-up that ensures the quality of renovation, we see that it is an integral part of the value proposition of public-driven one-stop shops, but that is not the case in most of the private-driven one-stop shops. And regarding upskilling activities, we see only some of public-driven and private-driven one-stop shop to offer that opportunity. Getting in more details in those business models. As far as it concerns the key partners, we can see that contractors and artisans are, for the majority of them, very integral partners in the delivery of the one-stop shop business model, as well as energy auditors. And we see the financial institution mostly for public-driven one-stop shops. Most of the examined business models have a holistic approach towards renovation, while some of the private-driven one-stop shop also offer individual renovation solutions. Full service is not the case for all of them, but again, we see public-driven one-stop shop being more oriented towards providing this thing. And financing with advice included, either from public grants or financing through loans. It is the case mostly for public-driven one-stop shops and not so much from private-driven one-stop shops. Regarding the customer relationships, we can see that almost all one-stop shops focus in providing to their customers dedicated personal assistance or guidance throughout the renovation, while the case of the customer having the ability them to choose the artisans to perform the renovation works is not highly spread between the currently operating one-stop shops. We can see as well that almost all of them offer a personalized renovation, an owner-centric renovation, while it is only the private-driven that are willing to bear the financial risk, while the public-driven are willing to bear the post-renovation energy performance risks. Considering the revenue streams, we can see that in various forms, since each model has a different way of managing the revenue streams, they come through specified fees for administration and management of the renovation processes. Some private-driven one-stop shop have brokerage fees. Practically, the artisans participate in delivering the various renovation works, pay some amount to the one-stop shop provider in order either to participate in the bidding process of one-stop shop or to be selected by the one-stop shop to deliver the work. We see public grants is a revenue stream mostly associated with public-driven one-stop shops. And we have also private sponsorships, which is the case for one of the private-driven one-stop shops. The cost structure is more or less the same as far as it concerns marketing and labor costs for the examined one-stop shops, while we can see private-driven one-stop shop bearing costs for training and workshop activities for the renovation work providers that they include in their circle of potential providers later on. We can also see for some of the examined one-stop shops IT-related costs that have to do either with the maintenance of a website that they have for their service, or in some cases platforms in which they gather data from the interested homeowners, or they use our platforms for a bidding process to select artisans to deliver the renovation works. As far as it concerns the commonalities of the examined one-stop shops, we can see that access to financing is something valid for all the public-driven one-stop shops. Pre-renovation audit is a key activity for almost all the one-stop shops that we have examined. Post-renovation inspection is valid for all public-driven, but not for private-driven one-stop shops. The management of renovation works is the case for almost all the examined OSS, and it is a core to one-stop shop, since it is expected the one-stop shop to be able to manage the renovation process for the homeowner. We can see similarities in technical key partners and special auditors and artisans. Also, the holistic renovation approach is similarity appears to all the ones examined one-stop shops. Dedicated personal assistance to the customer seems to be important for all the examined one-stop shop, as well as personalized approach. It is also a great commonality that we see for most of the examined one-stop shops that it's the OSS that decides which artisans to perform the renovation work. And a sad commonality for all of them is that all OSS fail to still to achieve enough scale of renovations, still developing. Of course, we see differences between them, with private-driven one-stop shop being able to deliver more projects, and private-driven one-stop shops still struggling to achieve enough scale of renovations to call them that they appear to be viable in the long run. As far as it concerns the differences, not all the examined OSS offer full renovation services. We see some of them, especially the private-driven one-stop shops, being able, in order to be able to have work, to give only parts of renovation, not a holistic approach to it. Of course, they are also open to the holistic approach, but they keep partial renovation as a part of their value proposition in order to sustain themselves in the market. Private-driven one-stop shops seem not to have access to public grants and schemes, and this is a question that how much this will affect their viability in the long run. As well as private-driven one-stop shops do not guarantee post-renovation quality. And we also appear that the bigger in size private-driven one-stop shops work actively in upscaling activities. And it is a case that we don't see from the public-driven one-stop shops, where someone could expect that they could actually actively work in providing training to artisans in order to have better quality artisans to deliver the renovation work. And again, it seems public-driven one-stop shop to attract more customers, and that has to do with various reasons, since the existence of a public entity behind those one-stop shops creates a greater level of trust to homeowners. Some key conclusions and way forward. Public-driven one-stop shops appear to be at the moment better positioned in the market. It is the case for all one-stop shops that they need to update their business models in order to be able to attract more customers for their service. The high price of renovation through a one-stop shop can to a certain extent explain the low interest for homeowners. The low scale of renovations delivered through one-stop shop threatens the viability of profit-making, private-driven one-stop shops. Public-driven one-stop shops are on one side non-profit organization, but they are also highly dependent on public grants and funding. And this raises a question how viable they can be in the case of absence of those public grants and funding. Post-renovation quality guarantees can be an issue for private-driven one-stop shops, as if you cannot guarantee the quality of the work, how the customer can select you as the provider for the renovation. Upscaling activities are required for higher quality, and this is something that even private-driven, public-driven one-stop shop should consider to include in their business model. And on the other hand, when we talk about private-driven one-stop shops, it is a question of scale, how we are going to achieve scale in order to stay viable in the market. This can be achieved with industrialized district-level renovation projects, but in this case, it is a question which actors should run such concepts and how even the private-driven one-stop shop providers could be involved in this process to achieve that. The large scale of renovation projects can bring new actors in the market, can bring larger companies that already offer turnkey solutions in renovation and actually force existing one-stop shop to optimize their business model in order to stay in the competition. And at least at the moment, smaller private-driven one-stop shop should focus in individual projects. And in the post-COVID era, this might create opportunities as more and more people seem to be interested to renovate and remodel their house. And with that, thank you very much, and I'm open for your questions.
Thank you very much, Georgios. Yeah, first of all, maybe a question with a bigger view. What is your feeling about the feasibility or the potential of one-stop shops in the European Union?
In my opinion, it is something feasible, but it is still something that needs to advance from the existing business models that we have. As you can see in the paper, on one hand, we have organizations that are trusted, public-driven one-stop shops are trusted, but on the other hand, we have to deal in most of the cases with local markets where those small artisans are the key players in the market. So we have to find the solution where it can combine the best of both sides. For example, in localized markets that we have the small actors, as we can see, they don't have access to public grants and schemes. How can we allow them to have access to them so to solve the problem of financing they have to the homeowners? On the other hand, we have the public-driven one-stop shops that they are based on their strength as an organization, and they don't invest a lot in upscaling activities. They might seem able to bear the quality cost of a renovation, but we see them not doing anything actually to upscale the skills of the providers they use. So it is a question how much both sides are willing to cooperate in order to create something that will have the best of both sides.
Okay. Yeah, I think this is an interesting point, and I know there are some other questions in the Q&A session, we will come to that, but maybe Migena, if you are still here, I would like to hear your opinion about one-stop shops in fact of your analysis from drivers and barriers. Do you think that one-stop shops might be a solution for that?
Actually, in the respect that they will manage and lead the process and facilitate it for the homeowners, they are beneficial. But the main question at the moment that was raised even in some other panels is that do we need to have the stop shops at the moment sustainable, self-sustainable, or but this varies between different countries. Actually, there are countries where there are a lot of public investment into this direction, while in Sweden the situation is a little bit different, I could say, and there is not this as much as sustained from public grants. But still, it's the way to go forward in a certain way, because it will be very time consuming in general for the homeowners to deal themselves with, and they don't have the knowledge.
And it is actually a good, the viability is a good question, because if we take it from actual one-stop shop development perspective, since one-stop shop became relevant to the discussion, we had almost 70 one-stop shops being developed throughout Europe. Currently, we can find only 28 of them operating, still operating or being on the very early phases of operation. And that creates the question, why so many of the initial one-stop shops have failed? What can we learn from that? Or what have we learned from older examples in order not to do the same mistake?
Yeah, okay, and that's perfect, because that leads us to the next or to one question from the Q&A session in Hoover. Did you also analyze the Dutch Energiesprong concept? And I don't know, maybe you or Cedric, you can say something, few words about that concept?
Practically, the Energiesprong is a part of a broader research now that we are doing in all the 28 operating one-stop shops, and certainly is an exemplary case for one-stop shops. But still, even on that case that still to be in full development, a fully developed business model, you can see that in the process, they made a lot of changes in order to stay relevant and sustain themselves in the market.
Okay, then we have another question about your record-based research approach. Can you give us a little bit more insights in that?
Practically, it has to do with presentations that the providers themselves give either to business conferences or to scientific conferences, workshops that they have given to artisans or investment parties. And as I said, this has been combined also with information from people behind those one-stop shops in order to have a more complete picture of how they deliver the model, how they organize, how they deliver their business model.
Okay, and then we have a third question. Have you come across many one-stop shop business that delivers additional to the building retrofit, or that delivers both building retrofit and renewable energy solutions such as photovoltaic?
Actually, there is, again, is a part of our broader research in the currently operating one-stop shop. One-stop shops. There are some cases in France that they go even beyond the energy renovation. They go to specific energy efficiency measures to be adopted. And it is the case in the startup model that presented here in Sweden. It is their planned next step to go on that part as well.
Okay. Yeah, and if there are no further questions, then I would say this is the perfect bridge to our next speaker, because we will now have a look at the roof of the buildings at the photovoltaic. So welcome, Diana Oege-Vorsatz. She's from the Central European University, and she will talk about the estimation of potential global building integrated solar energy supply. So, Diana, the stage is yours.
Thank you very much. So let me share my screen. Yes, so I hope you can see that now. Yes. So good afternoon, everybody, and I apologize I couldn't join for the whole session. I have to give several talks this afternoon, and there's a lot of competition. So after these really two fantastic talks, I want to focus on how much energy of the building energy needs can actually supply by just from the roofs. And the motivation is very simply this. The PV is presently the cheapest, the single cheapest energy source all around the world, or not all around the world, but in the vast majority of countries. Investments into PV are skyrocketing, and they are outpacing any forecast that was previously, even a year ago, that were provided even by international energy agencies. So they are very dynamically growing. However, the result is a mass-scale expansion of mostly photo PV parks. And this is one of the examples where when you look at the climate benefit, we are actually not really sure whether the net benefit is positive, since what we are seeing is that we have disturbed a huge amount of natural ecosystem, we have disturbed the soil. With that, we probably released potentially more carbon, but at least a lot of carbon at the expense of, yes, perhaps producing a lot of energy here, but then we have to transport it, which is again infrastructure that again has embodied energy and so on. So, but as opposed to that, this is another solution. So why don't we actually see how much of our energy needs we could produce from photovoltaic power, which is integrated into our present infrastructure, because most infrastructure, the roofs of the infrastructure and lots of the infrastructure we don't use, so it's much more natural to actually produce PV on from these, even if it's smaller scale and perhaps has more barriers and perhaps to somewhat higher cost, but at the same time, you're not taking land away from other important sources or needs. For example, in Europe, we certainly have a very, very high competition for land resources. Also, due to aesthetics, it's not really an issue anymore. These are, you don't perhaps even notice it, but these are actually, this is also the same power plant as I showed earlier. These are roof integrated tiles, sorry, tile integrated photovoltaic panels. So by now we can really make them not visible, and they can comply with any monument protection perspectives. So let's see it's very difficult, but this bar is at the top and I don't see the title of my own slides, but anyway, and I don't know how to make this top ribbon disappear. But anyway, so the purpose of the research is to estimate the technical potential of solar energy production basically worldwide, but we divide the world into different regions, but we are really trying to go into a very, very small scale, because the point is to have a spatially and temporally resolved, a very high resolution model. The original model was produced by Ksenia Petrichenko in her dissertation a couple of years ago. She named the model BICE, the Building Integrated Solar and Energy Model. And right now what we are doing is that we are transforming that model into on a new platform and integrating the new developments in PV technology and many other data, which since then also data sources have improved significantly. So the assumption is, so far we are actually using not only PV panels but PVT panels, meaning integrated photovoltaic and solar thermal panels. It seems that they are still the most effective solutions in terms of producing the most, supplying the most energy needs, for example, the buildings on which they are mounted. So we have, as I said, very high resolution. Time-wise, we have an hourly temporal resolution, and we have, as I will show, a very high level spatial resolution as well. So the key parameters right now that we are using as inputs are roof area, the meteorological conditions everywhere, and the technology. So according to this, let me show you the three specific sets of methods and assumptions that we have been using. So first of all, in terms of the meteorology, we are using extremely detailed, high resolution data, insolation data, and global radiation data from NASA. We are, through different different methods. And again, I forgot to say that this the model is further developed by Gergely Molnár, and unfortunately we couldn't register so many of our team at eceee, so I'm presenting, but he's the main brains on the updated model. Apologies. So with regard to the next step, the roof area, we are using the global human settlement layer database, which is a 10-meter resolution. So it's a very high resolution map. And in fact, we are even making it more correct by 1-meter resolution database. So it's a GIS-based supervised classification. And we are modeling both not only the roof areas on a very highly resolute model, but also roof tilting, since for PV panels, the roof tilting is also extremely important. And we are looking at and trying to model how much of what portion of the roofs are pitched or flat, and what angles they are at, which is really not easy, but that's needed for being able to understand the total PV solar energy potential. So in terms of the roof area availability, we are working with the so-called utilization factor. So how much of the roof areas are possible to be used best for solar technology. And this has different components: azimuth, service area, roof tilting, shading, and different other obstacles. And based on this, we are right now, these are kind of our utilization factors, still mostly based on Ksenia Petrichenko's dissertation, but we're updating these as well based on new information. And finally, as I mentioned, the technology has developed much further since 2014. So we have looked at a wide range of new PV technologies and their applicability in different geographic and meteorological zones. And are using the updated technological parameters. So as we have different findings, one important, which is an intermediate finding, is the roof areas available, or top roof areas of buildings available in the whole world. And we are actually forecasting that based on our other model, which is the high efficiency buildings model that we have been already using for over 10 years to look at global building energy demand. And there was a very successful presentation by my postdoc Shuran Chatterjee yesterday on the results of that model. So we are using that model to help us forecast the increase in building floor area, and as a result, the word floor area in these different regions. So what you see here are the IEA regions. So we are working incompatible with IEA data because we also supply are consistent with the different IPCC scenarios. So when you translate the roof areas into solar electric energy supply, basically the key finding is that even in 2020, just the technical potential of solar energy production is definitely enough, sufficient for total global consumption. So that means that yes, if you don't necessarily need to use land, valuable land, which is of course not everywhere land is very valuable, and there are marginal lands, but in areas where land has a major important other use factors or other demands on them, then actually you could solve mostly on a global scale and also on many regional scales. You could supply local energy demand by just integrated roof, integrated building photovoltaic energy production. Of course, it doesn't yet mean that that's possible at every building level. If we look at the solar thermal energy supply, we see that that's whether that is enough to supply thermal energy needs. That's of course not the same. Very different in the tropical regions and in the cold climates, and very different seasonally as well. And we are just working on on this matching the temporal distribution of our energy supply with the energy demand, solar and by the electric and thermal energy demand. And of course, whether you can match it fully, it really depends on the level of efficiency, and that was already a very important conclusion from Ksenia Petrichenko's dissertation a couple of years ago. So finally, yes, if you integrate all of these together, what we see is that the highest technical potential for energy production is due to single-family buildings. You see that in the majority of the regions, the light green has the biggest potential to serve, except of course regions where urbanization and very high density living is a different is more dominant. So there it's different. But it's also important to understand that in high-rise buildings, very often it will not be sufficient to produce energy just from the roofs. So very likely that in these buildings also the vertical surfaces will also be needed to provide, to supply the energy demand. And this is with the assumption that we worked with the passive house, the primary energy requirements of passive house levels, since we know that these passive house standards can be met basically in any world region and any climate. So that's what we took as a standard in terms of how to whether it's possible to satisfy energy demand by building integrated solar energy. So in terms of summary, yes, it's although our results are not fully final yet, but our initial results and also earlier Ksenia Petrichenko's dissertation have shown that yes, it is possible to supply global building energy demand, and not only heating and cooling, but total building energy demand by building integrated solar energy. The highest growth potential is definitely in the developing regions. And the most significant local production from PVT panels can be in single family and commercial buildings. But in tall buildings, we will have to use probably also the vertical surfaces if we do aim to go to net zero levels, to meet net zero levels in most building types. We certainly have a lot of plans how to develop our model further, and hopefully we will get several ideas also based on your questions and comments, and perhaps later on you're also welcome to send us emails. Thank you very much for your attention.
Thank you very much for your presentation. If you have any questions, please post it in the Q&A session or in the chat. But first of all, maybe one question. You said that the biggest or the highest potential for solar is on single-family houses. So what do you think are the barriers that we are so bad in using the surface or the roofs on single-family houses?
Well, I think actually there is a tremendous development of and tremendously increasing penetration of PV on single-family houses. But I think, for example, the previous talk was also an excellent one to show some of the barriers in general, how difficult it is that if you already have an existing building to step forward and to have a new to have something else done on your house. This is clearly a major barrier, or also information and comfort. Why bother? You know, most people just don't notice their energy bills and what's the point? And also by today, there are no strong subsidies, which is actually just normal since these have become quite cheap at the end of the day. But still, few people think that the bother is worth it just to reduce the energy bills over the years. So I suppose it would be more important to promote this through incentives and not necessarily financial incentives, but certainly I would consider making it more mandatory for new buildings, either to have, of course, there is a lot of competition for roof area nowadays, because there is also lots of pressures on establishing green roofs, not very best in all climates, but some climates are more appropriate for green roofs. Actually, sometimes these are complementary, because those areas perhaps have less or lower levels of solar irradiation, so it's better to have green roofs there, and in other climates it's better to have PV. But in urban areas, it's also important to have reflective roofs, and or at least white roofs, so light colored roofs, so in order to fix your albedos, in order to prevent urban heat islands. So there are certainly these three purposes are competing from a climate and energy perspective, so for roof areas. But as you say, nowadays most roofs are not utilized for any of these three, so more than 90% of roofs today are fully unutilized, and that's indeed a pity and a huge waste of resources, because instead we are developing land. I think actually what we would need is a more centralized concept for how to incentivize the use of infrastructure for major PV investors, because when there is a major big PV farm developer, they wouldn't consider, let's say, going to 100 buildings and negotiating with 100 buildings to establish a PV farm on 100 roofs. Instead, it's easier for them to buy a plot and put the PV farm there. But I think if there was more regulatory oversight, then we could understand that it would be important to redirect these investments rather into buildings, and not expect that it shouldn't always the building owner who should fix the climate. It's not every building owner which is responsible for our climate future, but really it should be our public and major energy companies and so on. So let's see whether, for example, the ETS will help if we have the residential sector, then whether this will help.
That's a good point to go to the next question, because this is also related to policy measures. As you said, for example, subsidies or other incentives are a good measure to promote the PV uptake. And the question is, what policy measures would you suggest in the EU to encourage more PV uptake?
Well, that's a very good question, and we didn't get that far in our research yet. But certainly, I think the most important would be to use carbon revenues to cross-subsidize the residential sector, because we understood that, especially in Europe, a very large share of the buildings and the area which has the highest potential for PV production is in single-family homes rather than commercial buildings. So it's very important that we do reach this market, but as we just concluded, that we can't really expect every homeowner to feel responsible for saving the climate, and they don't have or have other incentives. So I think if there is climate finance, or if there is even, let's say, cities or municipalities take this as an important way for them to reduce city emissions. There are many cities in Europe, or most cities have very ambitious climate goals. They will not be able to reach their climate goals without, I think, reaching out to this very substantial area of the roofs available or infrastructure available in their cities, and roof areas are definitely that. So I think they should develop programs where they finance from climate revenues, and not, I guess cities don't have that many climate revenues, but I think we definitely have to redirect in this direction. For example, ETS revenues or other carbon tax or other climate revenues, so carbon emission related revenues, and redirect into that. And public programs could help and take care of, let's say, the administration, the the hassle, so that homeowners perhaps could just say, okay, sure, come in on Wednesday, you can come and install, and homeowners shouldn't really have much more to do. So I think it's important that we don't put this responsibility at the homeowner level, but there is more centralized program for that, and we conceptualized even PV farms as a multiplicity of many roofs.
Yeah, and as you said, the country context is, I think, also really important, because yeah, the different countries, they differ a lot. And yeah, that's maybe a question regarding to your model. Do you, or have you included costs for the modules? Because I think especially the electricity prices, they are so different in the different countries in the EU, so that the potential, you said that you looked at the technical potential, but the real potential, I think it's really dependent on the heat and the electricity price in the different countries.
Right. At this point, we are looking only at the technical potential in the HEB 3-chip HEB model, where we are integrating all of this with building energy demand. There, we are taking cost into account. But I think because this is mostly a policy question, how subsidized are different prices and what policies you apply. I think it's really important for countries to understand that if they want to reduce their emissions, let's say they have to by very significant amounts, then and PV is ultimately one of our cheapest sources of energy production, then they just have to fix those regulatory failures or policy disincentives that if in some places these are costs are against, cost rationales go against installing new PV panels.
Okay, and then maybe another question, which is a little bit connected to that. Whom is your model addressing? Or maybe first of all, the question, is your model open source or is it closed source? So can everyone use it, or is it just an inside model from your company?
Very, very good question. I think because we are really in the middle yet in the research, and we are not we haven't finalized it yet, but because it's partially funded from the Sentinel EU Horizon 2020 program through the Sentinel project, that we will make it one way or another open source. So definitely it will be possible to use it, but I don't exactly know yet how that will take place.
Okay, and then the last question, to whom is your model addressing?
I think first researchers, because this is an intermediate step. So how much PV, building integrated PV is available, I think that's an input to many other types of research. For example, we are going to probably plug it in as one of the energy demand models or energy production models that under the Sentinel project we are using for creating a major European energy model platform. Also, in the end, of course, it's for policymakers as well, but for that, I think these other research steps are needed that you have yourself suggested, for example, regarding the cost and regarding the different policy environments. So right now, we have also made this mainly for our own purpose, for the 3-chip HEB model, the high efficiency buildings model, when we wanted to understand how much building energy can be supplied, how much of the global building energy demand can be supplied by the buildings, so how much can buildings become net zero energy buildings. But because we are moving on from just the building level and we are looking at community scale, energy communities. So this our model can be very useful for also designing energy communities, because of the high spatial resolution, we will be able to supply information on a very high temporal and spatial resolution to any community basically who is considering meeting their own energy demand from locally produced PV. So hopefully that in the end, this model will also be able to be applied at the more local scales and more actual planning purposes.
And have you validated your model against other models? Because I know there are a lot of PV potential models, and for example, one is also, I saw it in the chat a few minutes ago. Yeah, there's an example of another PV potential model. So yeah, what is, or have you validated against other models?
Yes, absolutely. And if I could find the, but it seems that my computer only offers me PowerPoint, PowerPoints and not all, everything that is open. Anyway, because I have on my computer open the Word file, which summarizes our comparison in less than a page. So yes, definitely we have been comparing our results to all existing models. We are kind of in the middle in some. If the models were produced earlier, the results were published earlier, we tend to be higher, our findings, which is kind of normal because earlier they did not anticipate this amazing development in PV, both prices and technology. In more recent models, we sometimes are under, sometimes over, but we are definitely in the ballpark. But actually, building integrated PV potentials for the world, we have not seen anything similar for many years. So that's definitely a research gap. Why these exist perhaps at the local level, maybe at the national level, but we have not seen, not found. So if anyone of you found some, then please do send it to us so that we can validate our model further.
Thank you very much. Cedric or Suzanne, do you have any further questions? All right, then thank you everyone for being here in this session today, where we talked about the contribution of buildings for sustainable cities. Thanks to all of you speakers. It was a pleasure for me to hear all of your interesting presentations. Yeah, and as we learned, innovative business models are really crucial to face climate change and to renovate our building stock. And hopefully we can renovate everything and also achieve an uptake in the PV potential of all the buildings. And if you're further interested in the topic of sustainable cities, then you're welcome to join our session tomorrow at 10:30. And yeah, then thank you everyone, and maybe see you tomorrow.
Thank you, Marcus.
Thank you very much.
Thank you. See you tomorrow.
See you tomorrow.